Stream Manager. Okay, so let's have a look if everything is working. And okay, we do appear to be live. Let me check for the sound. Okay, so the sound seems okay. Okay, so now we are Sunday evening. So I did stream Friday, Saturday. I did make progress. I created new textures. Okay, so basically I should show them here. So what do we got? No, not that. This. Okay, so what did I do yesterday? I did further work on the Voronoi texture, so I can create those textures, and both the blurred version and the not blurred version, right? And you know, I will leave that alone for now. I'm not 100% sure yet how I'm going to integrate that in the game. I'm not entirely sure if I like the background, what is supposed to look like grass. I will see. But I know what I want to do today, okay? I want slight distraction. Well, it's still related. What I want to do today is I want to work on polygons, okay? So I want to write some code that can draw polygons. So I'm talking about pentagons, hexagons, etc., right? And also modify them. And I want to make them look like, further modify them, because okay, the way that this tower defense game works right now is this is a bird's eye view, right? So top down. So imagine there's a little roof on the tower. That's basically what I want to create, like a texture that looks exactly like the roof. So I'm going to work on that. And okay, so what I have here, okay, so background render, the editor, it's kind of all put together with Schwingem and Spit, right? It's not done properly. I will keep doing it that way until I get a better idea of what I want the editor to really look like, and I'll do it then, because I want to focus on the game, getting the game right, and the editor is only supposed to be a tool. So I do what I do with that, right? But it's not the focus. What I'm going to do now is, okay, so we have the Voronoi textures, which I think is reasonably good. I mean, this could do with a bit more work and be improved, but okay. The blur also could be improved, but not too bad. And then there I just put the texture on the background, basically. Yeah, I just put the texture there, and okay, hold on. Default width minus. Okay, here I'm going to do just clean things up a little bit, right? So texture width. No, that's already here. So okay, texture width and texture height. Okay. And then here minus. So I don't have to hard code this. Texture width. And then here. So that should put the texture in the center. Okay, so compile. Okay, and we have errors, height. Where's height? height 758. Okay, okay. Here and there. Okay. Now that's working. Okay. And oh man. Oh. Because I did it in the wrong place. Okay. So that is how much of the texture we want to copy over. And then here is where to copy it over. Okay. No. Oh gosh. Okay. There you are with things just not working. What is wrong now? Okay, that's how many degrees I want it spun. That is CR. That is, oh yeah. No, it's working, but obviously there has to be an actual texture. Okay, oh da. Okay, so it's in the center. But what I want to do now is tau, and then what am I going to do? I don't know. T, I don't even know if I need T, but we'll see. And then I'm going to do 6. Will I do that? Yeah, okay. Draw texture polygon. Okay, something like that. I don't actually know. Yeah, okay. Good enough for now. Good enough for now. So here, underneath here, I'm gonna put this. Tau texture polygon. N, okay. Okay, so now int width equals Cairo image get width. I could have them passed on as variables, but I don't know. We'll see. Okay, height, and then Cairo arc. We're gonna put a red dot there in the middle. That's gonna be the first the first step. Okay, width over 2, height over 2. And then a radius that is 1/3. Boom. Okay, so that's just drawing a, well, if it's gonna work, that is. Okay, when I create those, I really should destroy them properly. Did I ever do this somewhere? Yeah, maybe not. Okay, Cairo create based on CS, and then Cairo destroy. There, and here now. And so we have our dot. Okay, oh yeah, I don't want that reddish thing on top right now. Or that greenish thing. Okay. Okay, so that's quite aggressive to the eye, so I'm going to reduce that a bit. What is the next thing I want to do? Okay, I don't want to draw a circle, I want to draw a polygon. So I take double degrees and I do 360. Okay, divided by n. Okay. You know what I'm gonna do? You know what I'm gonna do? I'm gonna do n equals 6 for now, okay? Never mind that other variable for now, okay? And so 60 degrees, okay? So like if you have a regular hexagon, the angles, they're gonna be 60. Oh wait. No, is it? Yeah, no, they're 60 degrees. Yeah. Yeah, 60 degrees. Now those are internal angles, okay? You're gonna see what I mean in a minute. So, what I want to do is, yeah, I have to decide how long I'm gonna make it. You know what? Okay, double. Side. I'm not even sure that that's the right thing, but anyway. Yeah, let's go with that for now. So what I'm gonna do is I'm gonna do double. Degrees 60 equals 6.282 divided by 6. Sine D for double sine, because I can't just use the word sine, right? Sine of degrees 60. All right. Okay, and then what I'm gonna do is Cairo move 2. Here, I'm gonna do center y equals height over 2. Center x equals width over 2. Center x. Oh, that is center X, and that is center Y. Move to, okay, center X plus side center Y. Okay. In fact, okay, I'm just gonna put a dot there for now. Okay, Cairo arc. I'm just gonna start with a dot. A green dot, okay? Okay. And then I'm gonna go then where am I going with this? I need a sine and a cosine, okay? So d sin, but hold on. Okay, that's gonna need to be d sin times side center X plus this, and then center Y plus, no, that has to be d sin times side. Okay, if I can get this right, the rest is probably not going to be too difficult. Okay. What did I do wrong here? Too few arguments. 5. So 5 is the radius. Okay. Okay. It's looking good, I think. I expected it to be on top, but it's at the bottom. Doesn't make a huge difference. Oh wait, maybe, yeah, no, I should simply have done that. Or do I want to go in clockwise direction? I can go in clockwise direction, it doesn't really matter. So in order to, I think that might be all there is to it. And then to be on the other side, I need to do this. This might work, hopefully will work. Yeah, okay. And then I take those two. And I do minus and minus. And then here I do minus, but that is plus. And now I have the vertices of a regular hexagon. So okay. What do I do next? Because I want to make it so that I can generalize this relatively easily. So okay, double vertices. I don't know what a good number is there. We're just going to go like this. And 2 for x and y. And then I'm going to go vertices. Zero equals so here that's the same with a minus. 2. Three. So 0, 1, 2, 3. What have we done here? Four. Second last one. And 5. Okay. So, int I equals 0. Well, I is smaller than 6. I plus equal 1. If I else Cairo move to vertices I 0, vertices I 1, line 2. Okay, and then we can have Cairo new path, and then we can have Cairo as a close path, I think it is, and then we can have Cairo, well, let's do Cairo fill. Okay, boom, and set a color, and the color can be gray. Okay, boom. And there we are. We have our hexagon. Okay. So that's pretty cool. Will I get rid of that? Yeah, okay, I can get rid of that. What is the next thing I want with this? I want to draw triangles. Okay, I want to draw triangles. So we put I equal to 0 again, while I smaller than 6, I plus equal 1. Cairo move to, and now what I'm gonna do is center X, center Y. I'm gonna do Cairo fill here. I'm gonna make them red, okay? I don't know for sure yet where I'm going with this, right? I roughly know, but I'm not certain. By the way, this was this big red dot. I don't need that anymore. And the sides, I'm gonna make it a bit bigger. Cairo, okay, Cairo line 2. And vertices I 0, vertices I 1, and then line 2, and that would be I plus 1 and I plus 1. Okay, and then if I equals, okay, I'm gonna put this I've put in 6 here. Okay, not all of those code, not all of that code here is general code. You know what? I'm gonna call it M. Okay, M equals 6. M if equals M minus 1, then we have to do things a bit differently. Okay, this is gonna have to be 0. So it's gonna roll back around at the end of the loop, right? Oh, does that work? I hope so. What's the problem here? Oh yeah. And then we have, okay, we can vaguely see the outline there. Why is it white? Oh, because that's the color I put there. Okay. Now, here is yeah, double red equals 0.8. Okay, and then red multiplied equals 0.9. So that means we're reducing. Okay, that doesn't look too bad. Now, that's roughly what I want. It's not, but it's kind of going in that direction. Okay. Okay, I'm gonna go for a quick bathroom break. And while I do, I'm also going to think about exactly what I want to do next because I'm not entirely sure. Okay. And we are back here. And okay, what am I doing? What am I doing with this? With this texture? Okay, the problem I have is I don't actually want it to look like that. I want one side that is bright and another side that is dark. Okay, if you imagine that this is the top of a roof, right? Like you see a tower, you're looking down on it. And I want to see yeah. I want to see like there would be one side of the roof that is bright and the other side of the roof that is dark, okay, depending on how the sun falls on it. Now, the thing I have done is I started here and then went clockwise around. I may start to regret that. Okay, maybe I should have started here or there because in my mind I want the dark side over here and the bright side over there. But yeah, maybe it doesn't matter though. Because I imagine, no, okay, if the dark side is over there, that means the sun is coming in this way, right? The sun is coming in that way. So yeah, maybe I should make it so that I can change the position of the sun as I want and just get whatever side I want to be bright. Okay? Yeah. Okay. And if I do that, um I'm starting to think, how will I... See, when we're talking about 3D graphics and lighting, people compute normal vectors. I don't know if maybe that's a bit over the top here for this kind of thing. Just a bunch of triangles. I mean, well, computer graphics arguably is always just a bunch of triangles, but okay. Let me see, 2D normal vector. Normal vector triangle. So, if those are the vertices, those are the... So that is line from A to B, that is line from A to C. So AB, okay. So you just subtract X and Y from each other, right? Okay. Then that is the dot product, right? What is N? N of AB is 3, 1. Okay, what is... Okay, I don't know what he means with N. So yeah, you subtract them from each other, right? And then you normalize. Yeah, but what's the normal again? Calculating a surface normal. A surface normal. Yeah, it's a cross product, right? Calculate surface normal. But the cross product gives you 3D things, doesn't it? Okay, is there such a thing like 2D cross product? Okay, so the length of A times the length of B times the sine of the angle of separation. Is that what it is? Okay, and calculate the determinant. Okay. I do remember there was a simpler formula for the cross product than this sign. And simpler and I suppose faster. So cross product, that is x times y minus, okay, x times y, but of the different vectors. Yeah, that makes sense. So v1 dot x times v2 dot y, based on what I vaguely remember, that seems right. v1 dot y times v2 dot x. Okay. Here and here. Okay. I'm gonna try. Okay, that's gonna be the thing with the cross product. But to the normalized vector, so it is clear to me that if we cross product two vectors, let's say a and b, then we will get a new vector c that is perpendicular to a and b. Yeah. Either in positive or negative position. That's okay. Also, it's clear to me the difference between unit vectors and non-zero vector. The unit vector is the result of normalizing a non-zero vector. We can say the unit, okay. We can say the unit vector is the vector divided by its length, right? If we have two vectors, one of them is, okay. My question is, if we have two vectors, one of them is a unit vector and the other one is a non-zero vector, let's say, okay, can we cross product them or must we normalize? So the cross product of two vectors is always orthogonal to the two input vectors. Its magnitude will be this. Okay, if you're looking for a unit vector, it's best to use a cross product and then normalize. Since if you normalize the vectors and then take the cross product, the resulting vector isn't guaranteed to be a unit vector. Right? But it is the unit vector that I'm looking for. So I just divide by the length, I think. We shall see, okay? Okay, I'm gonna do double cross product equals. Okay, and that is going to be vertices. Okay, there's going to be vertices of I, vertices of I, 0 because it's the x value, multiply with vertices of I plus 1, 1, because that's the y value. So we multiply those. Okay, minus vertices of I plus 1 and then 1 times vertices I 0. Okay, the x value. Did I get that right? No, I didn't. That should be I, and that should be I plus 1. Okay. I should declare it here that if I equals m minus 1, then it's going to be something else. Where I reply I plus 1 with 0. Okay. And then I'm going to do printf cross product. And I'm going to see what that gives us. Now, there's one thing I'm not sure about is the origin, because we've been drawing those triangles, the origin is the center of the texture. I'm not entirely sure how that's going to affect things, but we'll see. Oh, cross product is 0. Oh, haha, yeah. Okay. That look like big numbers. That is okay. That's definitely wrong, but okay. I think I want to make this into a macro. I think I'm going to make this into a macro, okay? So, define tau cross product x1, y1, x2, y2. And then, yeah, that's the same as x2, no, x1 times y2 minus y1 times x2. there. And so now I can do tau cross product. But what I need to do is, okay, so x1, so that's vertices I, 0. But I have to do minus center x. Yeah, not that. Minus center x, and then vertices I1 minus center y. I plus 1, 0. Vertices I plus 1, 0 minus center y. Right? Hold on, that wasn't even right. I plus 1 has to be replaced with 0. Anyways, yeah. Here. This is 1, 1. Okay. Okay, this is all wrong. Okay, that has to go here and that has to go up there. Right. Did that make any difference? Did that make any difference at all to anything? Hold on. I did not do this right, did I? Because... yeah, no, I did not do this right. The reason being, some of those x values are... no, wait, that shouldn't matter. Those numbers don't look right to me. So vertices 0, 1, 0, 0. Okay, I'm going to compute the same thing a different way, and then we can compare the results, okay? That will tell me. So, double cross product 2. So, what I'm going to do is I'm going to... I know the sine, okay? Because the sine is 60 degrees, right? So I have this the sine right here. All right, that's the angle of separation. So what I need to do is the length equals tau length something like that. So okay, I'm gonna write this function here. I'm gonna put it here, okay? Double x1, double y1, double x2, double y2. And then double dx equals return the square root of dx multiplied with dx plus dy multiplied with dy. Okay. So here, line length of, gosh, no, that's not right at all. That's not right at all. Okay. Basically, it's from the center, right? So center x. Okay, you multiply that with total line length. Center x, center y. And then you have those, right? And then you multiply that with d sine. Right? That's okay. That's and then here this has to be 0 if we get to the towards the end, right? Okay, now let's see what that gives us. Okay, product 2 definitely does well. Okay, the cross pro. Okay, when you think about what we're doing here, right? We're taking the lengths of the lines are always the same. So you take the length of the line, you multiply it with the length of the other line, which is also the same, and you multiply it with the sine of the angle of separation. That's always going to be the same number. Okay, that's always going to be the same number. Right, so when we saw the cross product formula, cross product, okay, The cross product of two vectors A and B is defined only in three-dimensional space and is denoted by A times B. O is defined only in three-dimensional space. Okay, I thought there was a two-dimensional cross product. Okay. The wedge notation is often used in conjunction with the although in pure mathematics this notation is usually reserved for just the exterior product of an abstraction. Okay. The cross product A times B as a vector is perpendicular to both A and B with a directional given by the right hand rule and a magnitude equal to the area of the parallelogram. Okay. The cross product is defined by the formula. Yeah, now the cross product is a number, right? So theta is the angle between A and B in the plane containing them. Right. Those are the magnitudes. So that's basically the length. Okay. N is a unit vector perpendicular to the plane containing. Okay. If A and B vectors are parallel, okay, the cross product is 0. Okay. What if here, oh yeah, okay, down to 0. Okay. But the cross product here is always the same. Right. Oh yeah. Okay. Right. Okay. Let me rethink that a little bit. What I really need is I need to compare it not with both vertices. I need to compare it with the rays of the sun. Okay, I need to compare it with the light that goes in. Do I? Well, it doesn't, yeah. It doesn't matter actually at this point. I feel like I've already made this way too complicated. Okay. I'm gonna try to think that through. Okay, so I have a circle. Imagine a circle. There's a light ray coming in, and then I have the angle. Okay, I look at the difference between the angle. So what would the cross product tell me? Okay, you know what I'm gonna do is I'm gonna do the following. Okay. I know what I'm gonna do here. I might regret this, but whatever. I'm gonna call this a cross product, and I'm gonna say I'm gonna have here 0 0. Yeah, 0 0 and 0 1. So if I do this now, that should always be different numbers, right? Oh yeah. No. What's going on? Hold on. Oh yeah, the length is always yeah. No. No. The angle has to change, right? The angle has to, so that has to be the sine of so I'm gonna have 2.62 divided by 6, so that's 60 degrees. Okay, this bit here 60 degrees, and then I need to multiply this with I. Okay, so that, yeah, so now the cross product is going to be this, it's going to be different, right? It's going to be different as I turn this around the place. Yeah, I'm so surprised by how big those numbers are. Let me line length. Let me see now. Is it doing this right? $150, yeah, okay. So if I want to do the normalized cross product, I think that's what I need to do, right? Okay, and then here I can do times cross product divided by 256. How did it manage to be green? Oh, well, yeah, okay, that's why. Right. Okay, so now we have here something that's quite bright, and then we have, okay, that actually looks quite good. What if I do this? Red is 1. Right, okay. Okay. what kind of range of values are we getting with that cross product? And what do those values even represent? Oh yeah, yeah, it depends on the side. Okay, the side leg, which is 150. Okay, so what we're gonna do is we're gonna say, okay, double percentage. We're gonna have cross product divided by 150 yeah. Okay, this is to normalize it, but then here divided again will give us a percentage. And then I'm gonna say red equals 0.5 plus percentage times red. No. Okay. So it's going to be at least 0.5 and then a certain percentage of 0.5. And then here, that's just going to be red. That's a bit too much, okay? So now there's going to be 0.8 at the most. Voila. Percentage. Zero, 0.5, 0.9. Okay, no, that's right. Yeah, I want a bit less of a jump. Okay, those are very strong differences, right? Okay, what if I do 0. Okay, 0 0.5, 0 0.2. That's gonna give it much less of a difference. This may be too much. 0 0.4. Okay, does that look good? I think that looks fairly good. Okay. Let me see now. Okay, there's a number of ways I can make this look more fancy. render tower render. So I have a radius of 30. So if we make the texture 60, let's even say 70 to give it a little bit of a margin. 70, then side then needs to be 30, I think. Yeah. Okay. And then if I want to copy that texture. Keys S is tau background save, tau background save. If I do S ls, it's not a background, but doesn't matter. No. Okay, if I just cycle through them. No, okay. Okay, so that didn't work. There's 1, 2, 3, 4 in the background. And I press S. Okay. Okay, I pressed it several times just to make sure, so okay. What? Hold on. Execute save background. Which one is the new one? 169.075.3.8. Does it somehow? Oh, I know. Okay. Okay, there we are. Okay. So 1600 minus 60 is, well, okay, that really just needs to go right. And then 1600, well, now divide by 2, 800 minus 30, 770, or is it minus 770? Yeah, and then 800, 400, so negative 370. It's times 800, isn't it? 900, so 450, 420. Oh yeah, okay. So that is, oh, somebody followed. Okay. Thanks for following, Jack CC. I don't know if you're still watching, but thanks for following anyway. So here, that's the texture. Okay, there is, oh, there you are. Okay. It's weird because it doesn't show up on the Twitch website. It just says 1 viewer, which I assume it includes me because I'm watching the stream. So anyway, I hope you're enjoying Jaxie. I just realized I should have put the background. I need to get rid of the background here. Okay, but why is it? So, okay, layer, select none. I don't know why it spills out like that. Oh, okay, there should be no radius, of course. Right, okay. Threshold. Okay, I need to add an alpha layer. Okay, up. So select none and then okay, so there's still a little bit of black dots there. Okay, maybe if I make it much bigger. Okay, that will do for now. So save as, no, up, export as, save background. I'm gonna call this tower.png. export. Okay. Then maybe here. Okay, textures. Cairo image surface create from PNG, and then saved backgrounds, which is now a really awful directory name. It should be called maybe textures, I don't know, but save background. Okay, and then tower render. Okay, and then here I'm gonna do, I have to do the copy surface. Where is it? Copy surface. Don't feel 86. Oh, okay, here. This. So T tower CS. Okay, and now, well, that should be 0, 0, 60, 60, 0 degrees, CR, and then here, that needs to be TX. Okay. So that's TOX. Okay. I'm a giant, don't really know anything about programming, but I'm studying at school, high school. I know just basics of C. Okay, that's cool. TOX. Okay, and then that should be minus. No, it should be plus 30. Hold on. No, minus 30. And then TOY minus 30. Okay. So now hopefully, no, okay, not working. Oh, nice. Nice, very nice. I mean, it's not how I want the towers to look just yet, but anyway, get rid of those circles. Okay. Get rid of this. Yeah. Okay. Okay. We got towers that look a bit more like towers than we had before, instead of the plain circles. Okay, I think this is a good place to stop. So I'm gonna wrap up here now. I'm glad that this looks fairly good. Okay, I'm gonna put more features on those roofs. Okay, make them look better. But and what I can do to have different types of towers, I should be able to just change the colors. They could be red one, they could be blue ones. They could have different levels of power. Yeah, I think it's starting to look good. All right. So that's a little bit of progress with this tower defense game. I will be streaming again next week. I hope you all enjoyed. Thank you for watching. Thank you for following, those who did follow. And I'll see you next week. Bye bye.